Hello, I am Jagdabi Shanmuka from Sri Venkateswara College of Engineering of 1VD 21 CS 065. Today, the subject is ATC and the topic is DFA, Deterministic Finite Automation. Let's have an intuitive view of automation. An automation is a machine that has input tape and can be put into any of the several states. A string of symbol is written on tape before the execution. The automation begins by reading the symbols of date from left to right. Upon reading a symbol from the tape, the machine changes the state and advances the tape. Basically, the input is read and the advancement is done. After reading the symbol, the machine files. The last state tells the result of the processing. Basically, the input processing and the output is done in simple words. We have transition diagrams to look upon this model. What is a transition diagram? In a transition diagram, each state is represented by a circle. Each final state is represented by a circle within a circle. Transitions are represented by arrows from one state to another state. Transitions are labeled with an input symbol. The final states are indicated by a circle within a circle. There is a following diagram that represents transition from state P to Q upon reading the symbol A. We have the initial state P here, and this the thing is red, and then the A is red, and then the transition is done to Q. We have a number of examples of automation. Let's take an example describing an automation that reports whether the input string begins with a zero or not. We can analyze the input get it started with a zero or not. And let's have another example here. Describe an automation that reports whether the input string ends with a zero. Basically, when we take a string, let's for an example, 1, 1, 1, and 0. So it ends with 0, and this condition is satisfied. And we also have another example. Let's take a look. Describe an automation that would read the input tape and report whether the tape contains the number or even number or an odd number of symbols like 0, 0, 0. It's not like 3, it's not, or 0, or it's an even. So we can analyze by that. And we can also describe that it would be a binary string and report whether the string contains even number of ones and odd number of zeros, and etc. It has n number of examples. The thing is, you need to try out different things and different things. So the next topic, definition of deterministic finite automation. A deterministic finite automation (DFA) is equal to QEOSRF, where Q is a finite of states and S is a finite in primitive alphabet and K is the initial state. And, and F and J is the set of the finite states where the transition function from K to E to K. That is the given formula. We have a function of DFA. The DFA begins with initial state S. Upon reading the input symbol, DFA changes the state according to the rule expressed by transition function. After reading the last symbol on the tape, the DFA halts. The input is accepted if the final state is an F. Otherwise, the input is rejected. The language of DFA. Let E belongs to 0, 1. This is your design. The DFA accepts everything that begins with a 0. We have example questions here. We have design a DFA that accepts every string that ends with a D. This was an example. 0, 0, 1. The basic example. When design a DFA that accepts only a string length 1, or like the string length 2, DFA accepts no string. Like DFA can even accept empty string. No string examples. Like it's flexible. And you have configurations. The given DFA configured with a pair of Q, comma, W, where Q is the current state and W is the remainder with encryption. Here, see a video of the configuration where Q, W. The next transition from resource to configuration, Q dash and W dash, where we say that Q, W is what Q dash to W dash in master. That is why W is equal to A W star. For some A which belongs to A, and there is a transition Q, A which is equal to Q dash, and which is denoted by Q, W, and N of Q dash, W dash. We have the configurations, the configuration Q, W, each with the configuration Q dash and W dash. Only if there is a sequence of configuration we have such that Q dash and W dash will change its steps. Q dash and W dash in step one. Where P is denoted by Q, W and M star of Q dash and W star. The relation of M star is the reflexive transfer closure of the relation and the language of the affair. The string W is accepted by it as if M star in Q command for some state Q belongs to M. The language of DFA is denoted by L of M, where L of M, where W, where M accepts W. Example of DFA. Let's have V is equal to zero, where V belongs to the bar. Let's design a DFA whose language of all strings contain 0. Design DFA whose language of set of all strings containing 0, or 1. The design of the DFA whose language set of all it doesn't contain a 0. There are any number of examples as mentioned. So we have DFA accept. Let's take an example here. Design a DFA to accept string of A's and B's and with the string AB. Let's take an example. B A B is a positive item. It changes with AB. It means that we can have A and B, right? So here the transition diagram here the total number of possibilities. Where is the initial state? Where is the final state? And the total number of things. And we have the possibilities, the diagram, and Q naught is equal to Q naught. Basically, these are the possibilities in the diagrams given. Thank you.